So what we have on the screen is something that I did in January. So I was doing a series of presentations comparing different public clouds and their performance for database workloads. And I did the graphing for this in the way that I had done graphing for years, which was using some OpenOffice calc templates and graphs through OpenOffice. And, you know, been doing it that way for 15 years. I was part of the OpenOffice project originally. But this had a number of problems. I mean, the graphs look fine, and they went fine on slides. But number one, every time I updated the data, I had to regenerate all of my graphs. On average, OpenOffice would crash about 3 times in the course of that operation. And anything I wanted to adjust about the appearance of the graphs had to be done by hand for each graph, which, since there were some 48 graphs in the presentation, was a little on the time-consuming side. So at this point, I decided it was time to get rid of doing graphs the old dumb way, doing all of my ad hoc graphs for stuff the old dumb way, and start actually doing it the smart way, which is with matplotlib and associated tools. So, now, one of the things that held me up for a while was that it actually I was actually messing around. I actually spent, I don't know, 2-3 years learning Python before anybody mentioned IPython notebook to me. Which was like, why didn't somebody tell me about this, like in the very first Python tutorial I ever took? How many people here used IPython on a regular basis? Okay, that's good. So to tell you that much about IPython, I mean, I found IPython is absolutely awesome, particularly if the stuff that you're going to be doing, like a lot of my graphs, is effectively a one-off. Because it lets you just go ahead and write a little Python code and actually execute something. For those of you who weren't familiar with it, because a bunch of hands didn't go up, what IPython Notebook is it's, wrong window. It's a little application that you actually run from the command line. First, you just install it, either using a packaging system, using pip, whatever. You install it, and you do, actually. And IPython actually allows you to do a bunch of other stuff for Python, but the most useful thing is this thing called Notebook, because Notebook starts up this little web application running on your system. I've already got it running out in this window, and it starts up running your system, and then we have this little thing that has a whole set of different stuff that you can actually look at via that from whatever directory that you started it up in. And you create these different notebooks that are sets of scripts that you can edit. And that's what we're going to be working in for the rest of this sort of presentation, because it's a great way to do these one-off graphs, because there's some features for it. So now, before I go further with this, I actually need to talk a little bit about why I kept using calc for so long. And that's because matplotlib, well, it is amazingly powerful, is also a god-awful mess. The problem is that in the early days, I'm talking to me the developer, but the first thing created was this thing called PyLab, which is a replacement for MATLAB, which is designed to be an interactive environment. And then matplotlib was sort of built around that, with its main module being this thing called PyPlot, which has all of the sort of graphing and plotting stuff. And then it borrows a whole bunch of libraries and stuff from NumPy very heavily. But the end result is that you have, well, PyLab is often the easiest and fastest way to do graphs and that sort of thing. It doesn't cover all of the functionality of PyPlot or some of the things that are only in the parent matplotlib class. And the calls, the function calls, and even the sort of order of operations for using PyPlot straight up versus using PyLab are actually completely different. So if you've been trying to learn Matplotlib and you've been seeing things like answers on Stack Overflow and they're using syntax that is radically different from the syntax given as answers to other similar questions, that's why. Usually one of them is explaining the answer in PyLab and the other one's explaining the answer in PyPlot, or sometimes in some of the more optional modules like Pretty PyPlot, which are also nice, but I'm not going to show you here. There's a bunch of other stuff out there. But as a result, it's a confusing thing, and there's a bit of a high learning curve, particularly compared to what we're used to in the Python world in terms of learning new modules, in learning sort of how all of this works. So be ready for the first graphs that you write from scratch to take you a while to actually get anything useful. But so anyway, so let's actually go to some of these graphs. So the first, now one of the things I was mentioning here is we've got the IPython environment, which is our sort of interactive mini IDE for Python. It's actually, frankly, the only IDE I use for Python. It's the only one I found useful. And we've got a whole bunch of operations and menus and headers and that sort of thing. I just wanted to show you these briefly before I hide them, because we don't actually need this stuff. Now, one of the things that IPython Notebook has, well, IPython has this in general, but IPython Notebook in particular, it's a bunch of these sort of magic commands. This is the one that I use most of the time, and this actually says, let's go ahead and display all of our graphs in the notebook. And then we get that. Now, one of the things to understand here is we're actually operating in sort of a single Python session. So even though we've got multiple code segments here, they are actually part of the same Python session, and so anything I load in an earlier code session is going to stay loaded. I discovered this the hard way a little bit earlier when I forgot to put a closed connection to the database connection in one of these segments. So when I actually started on this was my next sort of graphing project, which was to do graphs of a survey of the PostgreSQL user group in San Francisco. We were actually looking at the question of some of our venue hosts wanted people to sign NDAs, that if you see any confidential material while you're in our offices, you're not allowed to disclose it. And was this really a big problem for the users? So I took a survey using Google Surveys and then actually sort of crunched it in the database. You can actually, I can show it to you here. So we've got sort of our NDA survey here with a whole bunch of data. And actually here. Oh, how about AD? So it's actually pretty simple, which is that I took the Google survey stuff and then sort of crunched it down into sets here of which meetups did somebody, what the timestamp of the response, because we don't actually have a user ID, which meetups did somebody participate in, what was their general attitude towards NDAs, which was one of several different values, how frequently do they attend meetups, and do they have any comments. So then I actually wanted some nice graphs to present on my blog about this. So, what's appropriate enough for a survey is a pie chart, right? Because we're looking at what's people's attitude towards NDAs. So the first part of it is just pulling data from the database, which is pretty simple. Here we're actually just pulling data from the stats demo database, which is running on Docker on my laptop. And then we're just going to do counts, grouping by attitude, which is what ATT is short for, from the survey. So that's actually pretty simple right here. So we've just got a set of attitudes and counts, and then we're going to go ahead and insert them. Now, I said that Matplotlib and PyPlot and PyLab actually include a lot of NumPy. And so when you're actually giving numbers to be plotted, what they want is they want it in a format that NumPy calls as array-like. You can use a Python list for this, although, as a warning, not a list of lists. A list of lists actually has to be explicitly transformed, which you'll see later on. but you can use a Python list. You can use text that looks like a list or a space-delimited set of figures, and a couple of other things that NumPy can put into its own array structure, which is for NumPy. So right here, I'm just appending everything to a list, because we're going to do the list. And then the next thing I actually tell matplotlib here is how big of a graph do I want. For historical reasons, I believe, matplotlib uses inches, so that 6.6 is 6 inches by 6 inches. But don't worry about the arcane units of measure, because these are screen inches anyway, which means they don't actually relate to any real measurement of distance. And then in the case of a pi, it's actually really simple, which is we want two things. We want the series of numbers, which PyLab will automatically take a set of numbers that doesn't add up to 100 and turn it into percentages, and a series of labels. Now, this is one of the things that you're going to see with all of these charts, is that for pretty much every different way of charting in matplotlib, what the system wants is a set of arrays that are all in the same order. And where you often get in trouble making graphs is that you fail to keep one of those sets of arrays in the same order. And then you're spending a lot of time going, wait, there's stuff there, but it's in the wrong direction, and it's off the side of the graph, and what's going on, and that's usually the reason for those sorts of problems. But so here we've got the array of fracks that we actually built right there, a list of fracks, which is going to turn into an array. And then we have a set of labels, which is going to turn into a set of labels. And then we want to give it a title, right? And then, because we're doing this inline, we just hit the command show. Oh, and let's not forget to close our database connection, like I did earlier. So I'm going to go ahead and do that. And so this is our sort of initial graph. And that actually works pretty well. We got a graph there. Doesn't look very good, but it does have all of the relevant data on it. We've got all of the relevant data in a pie chart, so that's pretty nice. So that was pretty easy. So given that there was that easy, let's see if we can actually make it look better. Oop. Where are we here? Sorry, scrolling problem. There we go. See if we can actually make it look better. Well, actually, before we make it look better, let's do something else. So I mentioned that one of the things that NumPy wants is these array-like structures, right? And one of the things that that irritates me about doing a lot of this stuff is what we're doing all the time is we're getting a cursor from the database, and then we're iterating over the rows, and then we're adding those rows to lists or dictionaries in Python. This seems very inefficient. So one of the first things that I actually do is I say, well, if what NumPy want is an array-like structure, Postgres actually supports arrays. So why not just pull the arrays directly out of Postgres instead of iterating over the stuff? So this is that same chart, only what I've done is I've actually changed the database query. So we've still got that count query here, which is embedded right in here. And then we've got the second thing that we're going to do here is we've done that as what's called a whiff clause that allows me to say, run this query first and then take the results of that query and run this other query over it, right? So we're going to run the old count query first, the one that I showed you in the early example. And then we're going to aggregate it up into an array in Postgres and just deliver the array, which psychopg, which is the Postgres Python driver, will immediately turn into a Python list. And then the rest of this is what you just saw. So, got the graph again, same result, slightly different path to get the information out of the database. So, now one of the other things, so we want to actually make this look a little bit better, because like I said, I wrote these to actually put in my blog. And yeah, this would get the information across, but they're kind of hard to read. Be even worse if you're actually presenting it in a slide. Can you back there, can you actually read the pie labels on the individual slices? Okay, you can. Okay. We also don't have any percentages in the slices. We don't have other stuff. So I'm going to do a few different things to improve the formatting here. So one of the things that we want to do here is, I tend to feel that pie charts like this look kind of flat. So let's actually make it jump out a little bit. and one of the ways to do that in PyLab and Matplotlib is this characteristic called explode, which lets you actually take a pie chart and break the pieces apart. And you can actually break each slice apart a different distance if you want to. We're not going to do that here. Instead, we're going to have them all go 0.5 apart. And because we're delivering the arrays from Postgres, I'm going to have Postgres generate that array as well, just because it's easier to generate all the arrays in the same way. And then we're going to have the figure here, and then we're going to explode. Now, one of the other things that I want to do here is I would really like to actually have some percentage labels on those slices so people could actually see them. So let's add a percentage label. Well, so the first thing that we actually added here to our Py declaration is we added the explode. And so that explode takes a list, which is a list of how much we're exploding each slice, which in this case is all the same amount. And then the other thing is, on a pie chart, we've got this auto percent characteristic, this auto percent optional parameter, and the auto percent says, fill in the percentages for the pie slices. And then you can actually give it some sprintf style formatting for how to format those. This says basically just use whole percentage points. And then I want to make this pop a little bit, so I'm going to add the optional shadow parameter, which says give the slices shadows. And then the other thing is, because I'm going to be doing a series of these over similar data, I want all the pies to be oriented the same, so I'm going to give it a start angle. Otherwise, it tends to pick kind of random, trying to keep the biggest slice on top, which is not what you always want. And then, so then give it a title and go ahead and so graphically, that's actually a little bit better. We've got, sort of a more visually appealing with pop slices and shadows and that sort of thing. And we've got some percentages on there. But the text is still darn hard to read and completely out of proportion to the pie chart itself. So let's go ahead and fix that. So again, the same as before, only this time we're going to actually set font size and some font characteristics. Now, one of the ways that this is kind of irritating in plotting is that the font size for every label has to be kind of set individually unless you want to set a default font size for the chart overall, which I almost never do because I usually want, different elements to be labeled in different sizes. So what you do is you end up writing a whole bunch of list comprehensions where you iterate over things, right? So like here, for example, I'm going to set font size to 16 points for everything in the list of texts, which are my labels. And then I'm going to do it for the auto text, which is my percentage points. And then I'm going to actually make the percentages bold. And then I'm going to set a font size for the title and make it just a little bit more readable. So there we go, a little bit more readable chart. And so then we've got this more readable chart, and I could go ahead and paste that in my blog and go with it, which I was pretty happy with. And the nice thing about this was, as new survey answers came in, I could just add to the table and rerun these charts, and they would automatically be updated, which I had to do a couple of times, instead of needing to regenerate everything from scratch again the way that I was doing with calc. So, did I go too far? Yes, I did. Okay. Now, obviously, pie charts are nice, but they're not everything. We need to actually do some other stuff, and where I do a lot of other graphing is database performance, which among other things involves a lot of line graphs. So we're going to go over to a different table now. So we're going to look at this CPU table here, where we're going to actually look at I/O weights over the CPU table. So this is CPU data that we took from a busy period on a particular database server. Those look like. Those look like that. You just saw our output. So we're going to take all of that and we're going to move it into a set of times. We're going to group it by time. And then we're going to go ahead, once again, have Postgres produce the arrays in order to simplify things. One of the other things that you actually run into in pulling data from Postgres is NumPy wants floats for everything. And sometimes it will just automatically fudge other types of numbers that you give it into floats, and sometimes it won't. I've never been able to predict accurately when it will choose to do what. So often what I'll do is I'll coerce the stuff coming out of the database to be floats, even if it was originally an integer or a decimal. Actually, particularly where it runs into trouble is one of the things used in calculations all the time for in Postgres is this type called numeric, which is fixed size floating point or fixed size decimal point. And that gets converted to decimal in Python, which then which NumPy then doesn't like, particularly if you hand it an array of decimal. So coerce those into floats, and then assign a bunch of data here. We've got our time series, the IO weights, and the max IO weights. Now again, 3 parallel arrays that are in the same order. This is, where it's really useful to be pulling it out of a database, because we know if we pulled it out of a table, right, and in the table we actually sorted everything, then we can be sure that those arrays will be in the same order when we hand them off to matplotlib. So then once again, we need to actually set our figure size because it's going to be a long line graph. We're going to actually make it long and wide and short. And then we actually need to create this thing because, so here one of the things that's different, by the way. So the pie charts I was doing were all using PyLab. And you saw, using PyLab, one of the nice things about using PyLab is when it'll do the graphs that you want to do, it's generally simpler syntax. But for some formatting reasons for what we were doing with this, PyLab would not generate the graphs that we wanted. And so what we had to do was we actually used PyPlot more directly, which is a little bit more of sort of a technical interface, but it allows you to do a lot of other things. But when you're doing PyPlot, one of the first things you have to do in order to show a graph at all is you have to create what's called a subplot. That is, each individual graph is called a subplot. And the subplot's the one that actually holds all of the graphing data. So you can't just create a figure and release it as a graph. You have to create a figure, add a subplot, and release it as a graph. PyLab sort of conceals that for you. The reason why PyPlot has the subplot feature is that you can actually have more than one subplot in an individual image. Now, I'm doing a couple of other things here. This is actually because there's time data on the x-axis, and we want to format that time data. And that requires applying a custom date formatter to the data and then telling a PyPlot that the x-axis is time data, and therefore we want it to apply that formatting. And again, we use sprintf-like formatting here. Then we're going to go ahead and we're going to add 2 lines. Now, for each one of these plots that we do, for one of these lines, we give it the time series, again, even though it's seen it before, and then give it the measurement that we're giving it, which is, in this case, the average I/O weight, and then a second line in red for the max I/O weight. Set title, set labels, add a legend, apply the date formatting, which actually needs to be done very late in the process for reasons that aren't entirely clear to me, and then go ahead and show it. So there's our I/O weight graph. So we look at that I/O weight graph, and we say, hey, we're getting an awful lot of spikes in I/O weight. I wonder what's going on with that. Well, with just knowing the I/O weight, that doesn't actually tell us very much. So we really want to actually see a bunch of different data about the what's going on in the I/O system, and line it all up the same so that we can actually see what corresponds with what. So this is the I/O weight graph that you just saw. And remember I said about the business about subplots? Well, one of the reasons why you have this whole subplot thing is that you can add multiple graphs to the same image. So instead of just having one plot, we're actually going to have multiple subplots in the same image. And we do that by adding this extremely cryptic number. You saw the number 111 in the last one, right? Well, that first digit is how many subplots am I going to have in this general graph, right? And then the second number is second number is horizontal position, and the third number is vertical position. So for this one, I'm saying this subplot, it's going to be the first leftmost one in a set of 6. And so then I go ahead and I do the same thing, This is all the same IO weight graph that you saw before. Well, then I actually want to pull a bunch of information from the disk subsystem that I can graph out in parallel to it. These are all coming from, again, this was SAR data that we shoved into a database. So it's this disk right here. And we've got information on TPS and transactions per second and reads per second and writes per second and average weight and percentage utilization of the individual disk device. On this particular system, there happen to be 2 disk shares of any importance. So we're going to go through those. We're actually going to loop through them. Sorry, we're going to loop through them and actually go over each metric and create a separate line graph for that metric. One for each disk. And the thing is that we increment that little position, right? So the second one is in position 612, the third one is position 613, because we're just going to make them straight down vertical. And then we're going to go ahead and add a graph and therefore format all of the dates on there and go ahead and show it. This will take just a second. There we go. So now we can actually line a lot of that stuff up and say, okay, so here we've got our IO weights. Well, the IO weights make sense because we're getting, on disk 2, we're getting these huge spikes in transactions per second at the same time as the IO weights. So something's doing a lot of writing. Because, first thing you say, TPS, is that reads or writes? Well, the reads are pretty much flat, but the writes have those spikes. And then they call these other things. So we've already found out more about what's going on in the system because we can look and we can say, hey, all of those outage spikes that you're getting on a periodic basis are caused by these spikes in writes. Now, in this particular system, we did more delving into stuff in logs and that sort of thing and found out the spikes were being caused by database checkpoints and did some smoothing in order to make that less of a problem. But the graphs are what we start with. And this is actually part of our Postgres performance health monitoring stuff that we do. So that's sort of line graphs. Line graphs are a lot of fun. Now, the thing that I actually started, one of the things that's been on my to-do list forever for our monitoring stuff that I went ahead and put together for this presentation was to go ahead and let's do some more sort of modern visualizations like, say, a heat map. Heat maps are really useful for looking for certain kinds of problems. Particularly where I want a heat map is for CPU utilization because there's a difference between having CPUs switch off being at 100% and having one CPU be at 100% the whole time. So we looked at a system, overall utilization was 70 to 80% for the period we were looking at. We want to say, hey, what are we looking at in terms of individual cores being used? What's going on there? So once again, we're looking at that CPU data chart. So we've got the CPU and we've got all the different metrics that you get out of MPstat on a Linux system in terms of user, system, steal, etc. Right now we just care about busy versus not busy. So we're going to actually pull that out. In this particular case, we are formatting the dates in Postgres. The reason for that, remember what I said at the beginning about having this overlap between PyPlot and PyLab and Matplotlib and that sort of thing in the libraries? Well, mysteriously, certain classes will just not work with other classes. I found that the heat map and the auto date formatting would just simply not work together at all. Period. No matter how much I tried at it. So I actually did the date formatting through a different brute force method. And that is one of the things that you'll run into a fair amount when you get into doing a lot of different kinds of graphs, is that in the whole Matplotlib suite of tools, some things just don't want to work together. And here we're going ahead and pulling this. Again, we're pulling arrays from Postgres and adding, going ahead and adding in there. Now, this gets a little bit more complicated for a heat map because what a heat map actually wants is it wants a two-dimensional array. It wants an array for the x-axis and an array for it wants an array for the x-axis, an array for the y-axis, and then it wants a two-dimensional array for the data. So what we're doing is we're taking that busy stuff and giving it a two-dimensional array by CPU and time, building that up through the database loop. And then, like I said, because this is coming out as a list, we have to explicitly convert it to an array, or it'll error out on us, because it's a list of lists rather than being just sort of array-like. So then, once again, we're going to create our subplot. There's only one here, so we don't need to do positional. And then we call the heat map here with our data. And then there's these color spectrums that are already predefined for heat maps in matplotlib. There's like blues and reds and spectrum and a couple of other things. You can define your own custom color spectrum for your heat maps if you want to. I find either blues or reds tend to work pretty well for most of the heat maps that I generate. And then you need to actually do some other things, because there's some annoying stuff that the heat map leaves to default pyplot functionality that doesn't really work well for heat maps. All we're doing here actually is we're fudging the labels to put them in the center of each square for the heat map instead of on one edge, because it's hard to read. And we have to do that for both axes. This is just flipping what direction we are in the y-axis, whether bottom from top or top to bottom. Then we need to actually do a couple of other things for labels. We need to actually, so far, we've actually generated a heat map that doesn't have any labels on it. If I did a show right up here, we would have a heat map with no labels. So to add the labels, we actually have those two arrays that we already gave it of time and CPUs, and then we have to actually explicitly set those as labels instead of putting them into another method the way we would with, say, a line graph. I also need to rotate the time labels so they will be unreadable, so there's that rotation of vertical. And then we want to set a title, and then we actually want to show it. So there we've got our heat map of CPU usage by time and per core. And this was actually particularly useful in this particular case because, we didn't know what was going on with this initial spike in usage, and we think it might be an artifact of the data collection, which it often is when you see weird stuff in the first time period. But this thing right here, we discovered that they actually, we looked at that and we said, okay, something is squatting on that CPU for the entire monitoring period. So let's go ahead and look in the system and see if we can figure out what that is, because it's using a lot of resources. There were other useful things that we actually found out from this, like, for example, if you do optimization of hardware and that sort of thing, if you're going to have a busy system, it's actually kind of bad to have a cluster of busy cores on one socket and the rest of the busy cores all on the other socket for the same application, because you have memory sharing issues. And we discovered there'd been some bad system configuration, which was what was resulting in that. So that's, your sort of basic primer on actually doing interactive graphing with database data. Hopefully it was useful. And I actually have 5 minutes for questions. So do we have any questions?
Can you control colors? I mean, you have color explicitly, but
Yeah.
for shading and stuff.
Yes, you can, for pretty much everything.
I mean, so I was thinking for the pie graph.
Yeah.
Especially, color one.
Yeah, so you notice how, I was iterating through this. You can also iterate through the slices. So you can iterate through the slices, and if I was spending a little more time in this, for example, I would take away that blue and make it like a pale blue, so that the text on it was actually readable. And for some of the other colors, to actually make it pale. Also, the color blindness is a good reason to actually sort of always use explode, because otherwise you have a medium green next to a medium red, and people can't even tell that they're different slices. Yeah. So the trouble with it is that depending on what kind of graph you're doing, where you put in the color information is going to be almost completely different. because the color information on the lines are fairly explicit and they're actually there when you declare the plot, whereas the color information for a pie chart has to be done after you declare the pie chart and then iterating over the slices that have been generated. Other questions? Yeah, the question was, do we try to keep the IPython notebooks under version control? And if so, how? You can just check them into GitHub. The IPython notebook itself has this concept of checkpoints, which, let me actually bring the menu back. Has this concept of checkpoints that allows you to actually set points that you save it at. So it depends on what sort of a rollback you're looking at. Like often when I'm doing this interactive stuff, I will just set a checkpoint in IPython. And then if whatever I was doing didn't work, like when I was messing with the time formatting for the heat map, when it didn't work, I would just roll back to the checkpoint interactively. But then when I'm saving stuff over long periods of time, then I just check it into GitHub and upload it. Another question? The question was, am I using Python 2 because there are limitations on what's available in Python 3 for matplotlib? And my answer is the reason why I'm using Python 2 is because it's what we have on all of our machines at my company, that there are various machines where upgrading to Python 3 would be a problem. And therefore, we're just sort of standardize on Python 2 until we can standardize on Python 3. At which point I will start looking at what's supported. We've had, in terms of version control, we've had a bigger problem with versions of matplotlib itself. Like when I started the disk graphs, I actually had to do some rewriting because the ones that we have on our production toolkit were actually written for an earlier release of matplotlib, which is not backwards compatible with the current version. And those graphs need to be redone in order to use the current release of matplotlib. And we've had that experience more often than differences in Python version. More questions? Yeah. By the way, if you want to look at any of this later on, this is all going to be on my, what actually all already is, on my little personal GitHub page. The question was whether or not there's good resources for learning matplotlib and pyplot. Other than the PyLab tutorial, which covers the things that PyLab does, which is a really good resource, I actually have not found anything. For example, Venn diagrams and heat maps were stuff that I just learned completely from trial and error. There doesn't seem to be even be primary documentation for that, let alone good learning resources. So that's true for a bunch of that stuff. I would imagine that some of the scientific Python resources have chapters about graphing that I haven't seen that might be a little bit better than the sort of Stack Overflow approach that took over most of my learning. But I don't have a specific one to recommend. Okay, that's time. Thanks a lot.